All right, we are recording now. So if anybody has any questions, now's a good time. If about the situation, be okay. Let's see. Moving forward, make sure you time or if you need to. But we have interesting with sometimes or almost every time be there Monday and how many people are going to be there. Please get on the correct date. Another thing about somebody, I'm really lenient on due dates on the first week because it's the first week. So if you yeah, what else? What other announcements? I think that's it. By Sunday, you should have 10 points of independent work. It's still work page temporarily, not much longer. I think it's 8:01. So let me just finish up attendance and then we'll get. So Avery is here. This is here. Cooper is not here. Hunter is here. Elton is here. Is here. Reinhardt is here in WVSU gear. Isabel is here. Julia is here. Rogers is not here. Talbert is not here. Kylie's here. Lorraine, Madeline is here. Maddie is here. Galloway is not here. Cook is. Bergen is online. Samuel, first name Samuel. Spade is here. Burton is online. No Jones. Jones is not here. Canterbury is not here. Kraus is not here. Zach. Ray, last name Ray, is not here, and that's it. Am I missing any names? Okay, back into chapter 1. Anybody have any questions while I'm up? All right. A couple of you seem to have issues a couple of you seem to be having issues with the turning in, like how to turn in labs and independent. Today I'll be in office hours, so you can visit me physically or you can visit me online. Online might actually be better because I can pull up my screen on your screen but let me know if you need help. I'm here for you. For those of you online, the first word for attendance is going to be lab. I just got to finish talking about lab. Lab, word for attendance. And of course, you need your attendance points. And for the rest of you, you can send those in before 9 a.m. for extra credit if you want. All right. Got that going. See if it works. Yeah, that kind of works. This is where we left off, which is a good time to be talking about this because this is where we had lab on Monday. We've already talked about this, and if you have lab today, this is what we will be talking about, right? The scientific method. So we left off, we've already talked about observations, questions, hypotheses. This is one of the more important things to focus on because science is all about hypothesis testing. And another reason it's important to focus on that is because those are the questions people usually miss on the exam. First of all, they either completely forget what a and they think it's a question, or they go back to what they were taught in elementary school, which is not right. So that's one way they mess that up. And the other thing is they switch these two. They're very closely related. To that question, and it describes how you're going to test your answer. Where we left off. Any questions about here and up? All right, let's talk about experiments. Because so after you come up with your hypothesis and then you come up with predictions of how you're going to test your hypothesis, you do experiments. And as you can imagine, when you're in a semester, because of that, I'm not going to test much on the experiment part because you're going to have hands-on experience with it. So there's not going to be many questions about it on the exam. Also, as much as I could stand here and teach you about great experiments, lab getting hands-on experience. So I'm going to through it quickly because, again, you're going to have a lot of hands-on experience. And as far as the exam is concerned, so anyway, let's move forward. So if we're talking about the experiment, I have an explanation on the next. In fact, I have one or more variables, and you need to know what a variable is. Of a variable on the exam. Two, more importantly, throughout the semester. So a variable is any part of the experiment that can vary or change during the experiment. So if you're growing, 5 plants, each one in a different colored light, and use the same kind of plant, the plant isn't the variable, right? Because that's not going to change. If you're using the same kind of soil, you're not going to add soil throughout the variable, right? But we're more, we can change than we can. It's more. If you came in late, make sure you send me an email. Got here relatively early. So anyway, that's what a variable is. And again, you need to know. I'm going to use the word, and I might test you on it. But you'll get very familiar with variables. Anyway, the next thing is a control. Right? A control does not vary. And again, you'll get more experience with that throughout lab. So for now, I'm just going to brush past. The best way for you to learn it is to deal with it in lab. The aspects of all this are stuff we're going to cover next week. Again, let me go to the next slide before I take your questions. I want to wrap this up before you ask your questions. Here we go. To test your hypothesis, you have to run tests multiple times, changing and all other factors remaining constant. So some of you answered, like for the pre-lab question, I think there was a question about if you could do your own experiment, what would you need to control? That's what I mean by variables. Again, coming back to this idea of variables, right? Factors that controlled experiments. And again, I'm going through this stuff. Probably won't be on the exam. You're just going to familiarize yourself. But anyway, a controlled experiment is one that compares 2 or more groups that differ only in one variable that the experiment is designed to test. I wish I had a video. I'm going to share it with you. I'll find it. It's on YouTube. There's a lot of these kind of videos. They're not hard to find. But there's this lady. She's got some cabbage. About like, oh, she's got an accent that's very interesting. But anyway, she's got this cabbage, and she's talking about how bad GMOs are. GMOs are dangerous. GMOs are bad for you. They're bad for you. First of all, there is no GMO cabbage yet. But anyway, she thinks there is. She took this cabbage leaf, put it over a flame, and it did. That was her experiment, right? To demonstrate that GMO stuff is bad for you. But first of all, just because it doesn't catch on fire doesn't mean anything. But more importantly, she didn't do a controlled experiment. If she was going to do a controlled experiment, what she would need is a leaf from a cabbage that's non-GMO, which is what she actually had but didn't know it, and a leaf that was GMO, and then tried to burn them both. Does that make sense? She's trying to tell you that GMO cabbage is bad, and her proof is that it won't burn. Then she needs to have a control. Say, to demonstrate, here's a non-GMO cabbage leaf, and she puts it on the flame, and it catches it on fire. That would be a controlled experiment. So again, you need variables, you need control groups. Without this stuff, none of it's valid. Hopefully, when you guys do some of the papers you write will be involved with controlled or some either some real controlled experiments or some pseudo experiments. Hopefully, I don't necessarily, but maybe stuff passed by you and you'll turn in something that was actually a really horrible experiment for it, but it'll be a good learning experience because I can write back and be like, just so you know, this paper is garbage and here's why. Not your paper, but your source, right? The stuff you shared with me might be garbage, and it'll be a good learning experience. Anyway, any questions about what a controlled experiment and what a controlled group is and how these things are related? All right, experiment group 2, right? So again, using that same the video as an example, that lady, again, if she did it properly and she had a leaf that was a leaf that wasn't, right? The GMO cabbage leaf would be the experimental group, and the non-GMO leaf would be the control group. She's just demonstrating like this is what a non-GMO or this is what a GMO cabbage leaf does compared to a non-GMO cabbage group leaf. Yeah, that's it. So again, these are all things we're really gonna cover on that. Right now, it's more like a formal, brief introduction. Any questions about this slide? All right. The next word for attendance is a little bit more complicated. It's group. But instead of sending the word group, I want you to send a group that you like. It could be a group of athletes, could be a group of musicians. In a certain movie, I don't care. Just send me a group. And if it's really obscure, maybe let me know what it is. You don't have to, but I just want to make sure you're not making up some word. If it's really weird, I'll look it up. Like if you put up Rockheads, I'm like, I've never heard of the Rockheads. Who knows? Now I'm going to look. There's probably a band called the Rockheads out there. Anyway, any questions about this? All right, let's move forward. Some other stuff. I'm not going to test on it much. You're going to have so much experience with it. And read all. Best way to describe it to where you can remember it. So as it says, yeah. The variable whose change is not affected by any other variable in the experiment. So going back to your we said we're going to do an experiment where there's different plants. Each one of them is grown in a different colored light, and the color of the light in that was the variable, right? Because what the color of the light is, and that's it. An orange light's going to be an orange light for the rest of the experiment. A green light's going to be a green light for the rest of the experiment. It's not changing. It's not affected. Meanwhile, while we're growing these trees, these plants under those lights, we're measuring how tall they're getting, which is other things you can measure. You can measure their weight. You can measure their width. You can count the number of leaves, but whatever. We're measuring the growth. And in that experiment, the way we were measuring it was by height. So the height of the plant was the dependent variable. Because the height of the plant color we used. Make sense? All right. So again, you're going to have a lot of experience in this. And not every experiment, man, I cannot talk this morning. Not every experiment that we in our 101 lab is going to follow this. Think about the actual experiment we did on Monday, or the one we're going to do today. Yes, technically, well, let's see if anybody can guess, but between height and one of those, at least the way we set it up, was the independent variable. And don't feel bad if you get it wrong, because it's either one of them could be. It's just a matter of semantics. Said how we're going to do the experiment, that dictates which one of those is independent, which one doesn't. We could easily describe the experiment in another way, in which case the independent variable would be different based on the way we describe the experiment. Or here's a big hint: based on the way you're supposed to graph it, which one of those, the height or the wing's finger span, is the independent variable? The height is the independent variable. Yes. Because what we're saying is, at least the way we've worded that experiment, what we're saying is, or what we're trying to see is, does your finger span correlate to your height? Does your height dictate your finger span? But of course, again, this is all semantics. We could have said that the other way and said, does your finger span dictate how tall you are? In that case, it's a matter of semantics. But in other experiments we do, there will be a clear independent versus dependent variable. Anyway, another way that's been described is there's all kinds of ways you can describe it. I'm trying to have ways where you can easily remember it. The independent variable is the cause, and the dependent variable is the effect, so to speak. So like if I told you guys right now that I have pills that'll make you more intelligent, at least I think so, and I want to do experiments. So then, yeah, and then the way I'll do it is I'll give you pills once a week and give you tests once a week and see how you do on those tests, see if you do better or worse, right? So in that case, the dependent variable would be, we're saying that's dependent on the dose of my experimental pill that I'm giving you. So the independent of whatever drug I've discovered. Any questions about all that? All right. All this, another independent work idea if you want. And I mentioned this earlier in writing. You could do an experiments for independent work. And if you do this properly and you don't even need to do the experiment. Because there's so much work in just doing an experimental design and saying, all right, all these things are going to be the same. This thing's going to I'm going to take. This is the independent variable. This is the control group. All that stuff. That takes a lot of work. So if you want, find any experiment you want and write about it. You don't have to do the experiment because again, a lot of the work is just designing the experiment. Now, it might be a little bit more work because if you submit something that's got to be right away, I'll write back and be like, oh, you should consider changing this, consider changing that. So we might have a little bit of before you're finally, but it might be something fun. As long as it's about biology, the world is your oyster. Come up with any experiment you want. And again, like the one I just came up with, to make you smarter, know of, right? So I just came up with some idea. As long as you have a good experimental design. Anyway, any questions about this slide? So again, all this information is not from your textbook. I brought this in from various sources just so you can really remember the relationship between independent and dependent variables. I'm going to test you. Because again, this is not from your textbook. This is from a textbook. So I'm not going to test you, but it is something you should know. We don't actually do placebos in any of our experiments in this 100 level biology class. But you should know what a placebo is because unfortunately, one of the reasons you might need biology in your life is one day you or someone you love might come down with some sort of disease. So then you're doing research on the different medications on how to cure this disease. And again, this is the kind of background knowledge you need to know when you get started learning about that. Hopefully by the end of this, be starting fresh, you'll have a good background. Anyway, a placebo, it's a medically ineffective treatment. So again, going back to my example of this drug that I just made up that makes you smarter. Like I said, I would give it to you. Some of you would get 0 milligrams of it. Some of you would get 5 milligrams. Some of you would get 10 milligrams, right? We want to see the good dose. But whichever one of you got the 0 milligram pills, that would be a placebo, right? You'd be still taking pills, but there wouldn't be any of that medication in it, and that would be a placebo. That's just one example. It's medically ineffective treatment. And it, again, like I was kind of hinting at, it allows the placebo group to serve as a control group. So all of you who are taking the 0 milligram of my new medication that I've just made up, you would be the placebo group. You would be receiving, you'd be the control group, taking an ineffective treatment. The placebo group doesn't know they're receiving. Point, right? Because otherwise, if you're getting 0 milligrams in the pill, but the idea of a placebo, I don't want to have something that's ineffective, but they don't know it's ineffective. Because there is something called the placebo effect. You can look that up for independent work. I don't talk about it right now. But basically speaking, the placebo effect is when people think so they start doing better. Whatever the medication may be for. If I really did do that experiment and I was just giving, sugar and you didn't know it, you might better on exams. If you thought to yourself, man, I'm taking pills to make me smart, surely I must be getting smarter. Anyway, if we're talking about this, about not knowing that you're receiving the placebo group or that you are in the group, then we have something called double-blind experiment. That's when neither the participants nor the experimenter know which is which. So in that case, instead of me giving you the pills because I know which ones are which, I would have my TA do it, right? And I would say, all right, give these people pill number 1, give these people pill number 2, give those people pill number 3, so on and so forth. All he would know was which one is pill number 1, pill number 2. He wouldn't know which one of those is the placebo and which one of them has 5 milligrams or which one of them has 15 milligrams, whatever, right? In that example, that's how that would work. In the double-blind experiment, nobody would know what dosage they're getting. Anyway, any questions about this? This is it for placebos. And again, I put a big X through this to remind you, this is not from your textbook, so I'm not going to ask you about placebos on the exam. At least I don't think so. So my plan right now is I most likely will not. All right, this is an example from your old textbook, but I love it. I'm not going to test you on it because it's just an example. But this is a great example of how people use the scientific method in their everyday life, and they just don't think about it, right? Thinking scientifically is actually quite natural. Now, you probably don't think about the steps and say, all right, step 1 is this, step 2 is this. You don't think about the steps and make sure you're doing them properly. You just do this naturally. Can anybody tell me what that thing is? Good, it's a remote control. So let's say you sit down, you're about to watch your favorite show. What is your favorite? Anybody tell me what their show, or not, what show is anybody watching right now? Anybody? What is it? Okay, I don't even know that yet. I saw that just came out. Haven't seen it yet. I'm watching BoJack Horseman right now. Almost finished. Anyway, I digress. All day. So anyway, you sit down. You hit this power button because you show, and it doesn't come on. I'll go ahead and tell you the observation. And the observation is my TV not turned on. So let's see if anybody remembers what's the step out. And if you can't remember through the logic, you do if you sit down and you hit the button and your TV on. What's the first thing next? The question is, what the hell is the question? No, why is this not working, right? So and then again, this is written not exactly written before, but that's okay. Yes, next question comes to the hypothesis. And the one that your old textbook uses as an example is the remote's batteries are dead. That's one hypothesis. So again, you try to turn on your TV, it won't turn on. You say, I wonder why. One hypothesis is the remote's batteries are dead. What are some other possible hypotheses? There's a bunch. You hit the power button and your TV doesn't come on. What are some other hypotheses other than this? Yeah, so this says the batteries are dead, but the hypothesis could be the battery maybe not be any batteries at all, or maybe they're not in there properly. Maybe your kid dropped the thing and now they're all come out a little bit. What else? Your TV's unplugged, right?
Right, remote.
You've got the wrong remote. TV's broke. Hypothesis. But anyway, we'll stick with this one. So that is your hypothesis. Now here, again, in real science, you always have a prediction, or at least one prediction for your hypothesis. But in obviously when you're not really doing the scientific method, you might not. But because here, right, in the real life, if you thought the batteries are dead, what would you do? You'd probably, you replace the batteries. But if you're doing it scientifically, you would write a prediction and say, if I replace the batteries, then right. But obviously, that works. Usually, in real life, if you're not experiment, you very often skip it from hypothesis to experiment. In this case, do the experiment. Either it works or it doesn't. Right. So if it works, let's just. If it does not work, you replace the batteries. It doesn't work, then you need to go to the board, right? It's like, okay, well, I come up with your hypothesis, the batteries, and it's still not turning on. So then we use one of the other ones. Is it are the batteries in? Is the TV unplugged? Right, all those others, right? You keep coming through with hypotheses until you out, right? Here's where it's a little bit unrealistic, at least in this picture. You do the experiment. Let's say it does work. You hit the power button, your TV comes on. In real life, you're done, right? You're just trying to watch a show. So but if it was just real science, yes, your experiment real science, you would go back and test your hypotheses in other ways, and you keep doing it. And then you would write a paper about it when you're done. But, this isn't real science. The point here is that you all do scientific thinking in your real life. You don't mean to. Before I move forward, I'll let you know this will be a test question. But I'm going to come up with some random hypothetical situation. From that random hypothetical situation, I'm going to say, what is a prediction for this? What is the situation? I would describe it. I would say you sat down on your couch, you're running to watch your favorite show, you hit the button, the TV doesn't turn on, right? I describe that scenario, and then I say, what's the observation? And the TV doesn't turn on. And then I would say, which of these is a question? And there'll be a bunch of lists or a list of things, and you choose the question to that situation. And then I give you a hypothesis and a prediction and all that. So again, for the exam, rather than me the definition of a prediction, a hypothesis. Actually, I probably would do also a definition too. Just definition. I'll give you a scenario. You choose, out of a bunch of different words, what is the prediction? What is the hypothesis? Finding it, I'm going to ask you to recognize it. Does that make sense? Okay. Sort of like if I wouldn't ask you to define what a dog is, I would give you multiple choice and say, here's a cat, here's a dog, here's a cow, and of these animals, what is a dog, right? I'm not asking the definition of a dog. I'm just saying, given all these things, you need to identify. Same here. Given all these things, identify the prediction, the hypothesis. Any questions about this? All right. The third term work. It's not even going to be one word. Your fingernail. That was the next word for participant. Excuse me, I keep saying attendance, but that's technically it's participation points. All right. If you download the PowerPoint, you can read all this. I'm not going to go through this. I wanted to give you some examples between a prediction and a hypothesis, which I've already done in the first lab, so you can read that. Here's yet just another example. Big ol' do this because again, this is just an example, so I'm not going to tell. First of all, it is an example, and I almost always do not test on it. Second, this is not coming from your textbook. Anyway, it's just an example. You can read it. If you have any questions after you read it, let me know. I'm not sure if I'm going to ask you questions about this on the question mark. I really hate that it does that, but be a clean question mark. But between basic science and applied, some call pure science, knowledge, and applied science is basically technology and it's problem solving. And both of them can work together. Use DNA structure as an example. So because I think this is a great example of how they can both work together. So, like I said, last time we were here, about how I was trying to find the genes that are responsible for trichome growth on watermelon plants, the thing that makes them fuzzy. That was basic science. I was doing pure science, right? I was doing science for the sake of knowledge. Don't really care what genes are responsible for that. No one else had discovered that yet, so I wanted to discover it. I was trying to figure that out. I said the same person could do the same experiment, but it could be applied science. They might be thinking, they might be watermelon breeders. I'm like, all right, well, we are less pesticides, but we also want to get rid of the insects. What if I can come up with a watermelon breed that has to protect it from insects? That person the same data as me, same problem, because for them, they're trying to keep insects off their. For them, they could a new breed watermelon and make a lot of money off of it. For me, again, doing the same thing, but just for the sake of knowledge. Anyway, any questions about this relationship between basic science and applied science? Okay. Put a question mark through this too. I'm going to ask you about peer review. This is another one of those things that we're just throughout the semester. Hopefully throughout your independent work, turn in some papers that are based on peer-reviewed journals. But if not, I can almost guarantee you some of the stuff you turn in will be based on an article, and that article will have been based on, and the situation allows it, I can dig in forth, and it'll be a good learning moment. But anyway, basically it's this. Their findings, and they do all the work instead of just coming out to the public. What they do is they submit it to peers, right? Sometimes you know them, sometimes you don't. Sometimes they're anonymous. Either peers are experts in their field. They look at your work, not just one of them, but a bunch, and they make sure it's legit. And that's what peer review is. It's not perfect. Sometimes things do get past peer review, but generally speaking, if you read something that's been peer reviewed, you can trust in it. And I will go on and on about this throughout the semester, about how humans are biased. But this is still the best we have, right? At least we make an attempt, because it's not just one person, right? So for something bad to make it through, it would have to trick a lot of people, or a lot of people would have to be lying. And more often than not, it's lying, and they got past and tricked a bunch of people. But anyway, that's peer reviewed. We'll talk about it throughout the semester. It's really important. It really is. So before we move on, the opposite of that would be like for YouTube. Any crazy, I make it look good, and you could make it look really good, official, and make some video about it on YouTube. I could claim anything, and so could you if you could know just enough to trick people, right? You could put it out there, especially if it's on YouTube. People are going to believe you. I'm like, I did my research. What they mean is they. So anyway, yes, peer review, very important. Not perfect, but it's the best we have. The internet, I call this the misinformation. Come up with anything and probably find evidence. I keep using Bigfoot as an example. Scientifically, there's absolutely no evidence of it. But I bet if you were to look it up on the internet, some really convincing articles that really make that argument that Bigfoot, or anything, I'm saying, come up with some crazy thing and look it up. Hitler, one of the reasons he was crazy is because, I don't know, he had syphilis and therefore never had sex, and that really pissed him off because he didn't have sex. I don't know. I'm really making. You probably find somewhere on the internet even has evidence to support it. Not peer-reviewed evidence, but evidence. Anyway, any questions about that side? Okay. We're going to go through this also very quickly because I'm not going to tell you. This is stuff I want you to keep in the back of your head as we go throughout the semester, as you do your independent. Pseudoscience. This is so funny, too, that I don't test on this, and it wasn't any end of this semester. Hopefully it's how to identify and avoid pseudoscience. Because biology, yes. But notice no one said you had to take biology, right? Biology specifically. Reason is because biology is science itself. Scientific thinking would help a lot of problems. So I'm going to beat that dead semester. But anyway, pseudoscience, what is it? It is a field of study that is presented as having some basis. So again, like I was saying, yes, some people can make, but some people, especially if they're smart and they know at least a little bit, then they can make really convincing arguments, really convincing lies. So you should be able to see it. There's several indicators. You don't need to write this down necessarily. Does it have, is it based, anecdotal evidence is based on a few examples and don't support the generalized conclusion. Somebody who got to the beach, they've never been to the beach before, jumped in the water, and bit their leg off. It was like your best friend. You might be a little bit more afraid of jumping in the water. Now I can show you how safe it is to be in the water. Safe. The chance of you getting attacked by a shark, very big. If you have this one story it's also a whole story, right? I could show you statistics, graphs that show you don't get attacked by sharks, or someone else can show you a picture of a shark attack, right? The more important evidence, physical evidence I gave you. However, the picture of somebody bit off, that's more powerful evidence, right? Let's be honest. So that's what you have to be. Statistically, it's useless. Anecdotal evidence is usually useless, but it can be very strong. Somebody who took a vaccine, and then the next day, next month, they came down with some, and then they told you, oh, it's definitely because I took that vaccine. That's anecdotal evidence, right? I can show you in the world to show this vaccine has nothing to do with this injury. This doesn't matter how many numbers I show you, right? You're like, well, my Aunt Becky, next thing you know, she lost a nipple, whatever it may be, right? So again, anecdotal evidence is horrible. Try to recognize it because it's very powerful. Even me, fixed jets when I was in the Marines, and I've flown. Statistically, flying is pretty safe, but I still hate it. I try to get as drunk as possible before I get on because I hate to fly. Scientifically, statistically, I'm safe. I also know that probably one of the safer times to fly is when you're in the air. Times to fly is when you're landing. Still, that's logical. That is also one of the other dangerous parts. For some reason, that. And I also don't mind landing because I know it's about to be over. But logically, I do know this. I've read the studies. That's the most dangerous time is when you're landing. But yet somehow I'm at ease because it's anecdotal, right? The mind's a powerful thing. Anyway, that's the anecdotal evidence for exams in this class, but it's really important to recognize. The other thing you need to recognize in science is the source of the information. Hopefully, I'll be getting on independent work. But if you make a mistake, I'll be like, hey, have you considered your source? When that Impossible Whopper first came out for Burger King, I read something about how the ingredients in this fake meat is really bad for people, especially males, because of the details. And I don't know, it could have been true or not, but here I didn't have time to really dig into it. But I did look at the source of some digging. So it was an article, and that article quoted somebody. So I went and looked at that person, and that person had a bunch of originally written that information. This beef association. So yeah, of course that person is going to be like, look, all the evidence that says not eating beef is bad for you, right? So consider the source of information. And don't get me wrong, it doesn't mean that's always incorrect. Again, this guy, maybe that was correct, but the source is definitely iffy, right? Obviously, this guy has some biases. Anyway, moving forward, another thing to consider. Oh yeah, again, source of the information wasn't peer reviewed. So this information was not peer reviewed. This was just he was a veterinarian. I'll give him that. But a veterinarian, yeah, that's right. So he's talking about human health. Anyway, it wasn't peer reviewed. It was from at least an association that was trying to sell you something. Books are back to this PowerPoint, which you guys all have access to. But it's a good little comparison between science versus pseudoscience, right? So read it if you want. Keep it in mind. Hopefully, you will be learning throughout the semester, especially through independent work. So again, if I have time to really dig into what you're sending me, then you might learn from it. You might give me a bad source, and I might say, hey, consider your bad source. Here's another thing that's not in your textbook, so you can take a look if you want a little checklist, right? So if you're considering the source of the information, is it current? That's another thing I see. People like share something from 2001. I'm like, oh, things have changed a lot. So yeah, we may have thought that back then, but that's not the case anymore. Is it a primary source? This is not big for you guys. I almost guarantee almost everything you turn in for independent work will not be primary. I prefer it to be primary evidence, a primary source if you can, but I understand if you don't, because what a primary source is a peer-reviewed article, and I have to admit a lot of those are really hard to read, especially if you're not in the field. So yes, some of it might just be gibberish to you, but then again, you could read somebody else, especially stuff I share with you. Somebody may have written an article based on that peer-reviewed journal, and then that is more easier to read for the layman. Anyway, Yeah, can you identify the authors? I've seen that sometimes, like some anonymous person just put this out there. Does the author lack potential conflicts of interest, like the beef thing I was talking about? Are references cited? That's another big thing. You probably won't be much for that, but a lot of times people send in a paper, and I'm like, dude, what? Have you read that paper? There's no reference. It just said this statement, and there's nothing to back it up. Anyway, I'm not going to read through that. You can read through it. We'll go through that throughout the semester. Ooh, look at that. That's the end of chapter 1. Let me see how much time we have. 10 minutes. Start chapter 2, guys, because we are a little bit behind. We should be done with chapter 2 by the end of this week, and that's not going to happen. So let me at least pull it up. And while I'm pulling it up, does anybody have questions about anything? All right, so to remind you, as you just saw on that last slide, there is a study guide. It's online on my online. You can find it. You can get extra credits for doing it. And like I said in the first class, use those study guides to write the exam. So if you do the study guides, you'll have seen most of the questions. Now, granted, I do reword the questions on the study guide. They're not going to, most of them won't be verbatim like they were in the study guide, but they will be there. You know what? Yeah, no, I'll keep doing this. All right, the next word for attendance, since what we're having, is intermission. Least I can do is get this thing downloaded and at least do the introduction. That way, when we get back here on Friday, we can hit the ground running and not go through all this. There we go. Not that one. No, that is it. That'll work. Chapter 2 PowerPoint. Now open it up. Oh, while I have you here, let's just do this. While I have you here really quickly, I know this is the PowerPoint, but if you were doing a lab or if you would open up the document just like this, and you go up to the top right, share button, put my name in there, and that's how you share it. Make sense? All right. Same thing with labs. Don't delete anything, or don't feel like you need this one document for pre-lab and this one document for lab. It's all in one document. Open that document, share it with me, and use that document for the rest of the week. Here we go. Anyway. There we go. Really quickly. What we're going into next is the chemistry of life. So basically, we're now finally getting started. Chapter 1's basically an intro. What is biology? What is science? We're done talking about all that. Next thing you need to understand is chemistry. And it really stinks. A lot of people blame you. But to truly understand everything that's coming later in the semester, you need to understand chemistry. Don't get me wrong. If you're learning this and you're having problems with it, don't get me wrong. You can still basically understand what comes after this and understand it enough to get good grades. Even evolution, right? To even understand those big things, you need to understand chemistry. So here we go. Actually, how many of you took biology because you did chemistry? Yeah, see, sorry. Is this. But the good news, how many of you had chemistry before? Good, some of you. So for you, this will be a review. Actually, for a lot of you, this will be, and I'll tell you now, this is the easy equations. There's almost no math involved. There's no stoichiometry. So let's jump into it. This is from your old textbook. It always likes to start off with some pictures and talk about why things mattered. So I incorporate the textbook. I tell, we'll do that one last. Yeah, pour it on some fries, right? So as you're going to learn in this chapter, you're going to learn about sodium chloride. And this is really interesting, and I love it. I love harping on it. People will try to scare you with chemicals. So, and they're both deadly. Water and chlorine gas is a poison that we literally, right? So these things are dangerous, deadly. Fine. Keep that in mind when somebody says garbage, like, oh, you're buying that lotion. You shouldn't buy that lotion because it has this ingredient in it. And then they'll take it and show you accurately. They go, look, this is but that one ingredient a poison when you can combine it with other stuff. So salt is a great example of that. Kind of metal that is. I like to steal that around here. That's just one of the elements. We'll talk about that a little bit. Here's a little bit harder. Overall, the big picture, not specifically what this is, but overall, can you tell what the big picture is supposed to be? Yeah, it's a coral reef. Most people don't guess that here. I'm impressed. But yes, that's a idea what's going on with this particular piece of coral. Curious if anybody knows. It's bleaching, and that's because of a chemical reaction. The chemical is caused by stuff that humans are doing, and we'll talk about that later in the semester. So they cause this chemical reaction in water, and it's killing the coral. And as you'll learn later, I've already had 108. You will know that you might think, oh, who cares, dying. But it's not just about that one coral. That one coral is a peak of the ecosystem. So if that, the whole ecosystem's unhealthy. And if all the ecosystems are unhealthy, so are we. Anyway, any questions about that side? It's very unimportant. This chapter is broken down into 3 parts. We're going to talk about the building blocks of molecules, water, and then we're going to talk about biological molecules. Now, in your old textbook, this used to be 2 chapters. This would be 1 chapter. This was a chemistry chapter, and then we had a 3rd chapter called biological molecules. I'm only saying this because I know some people do. So let's talk about this. Building blocks of molecules. This portion of chapter 2R, you should be able to just, you probably already can, so that should be a quick review. And you should be able to describe the interrelationship between neutrons, and electrons, and the way in which electrons can be donated or shared between atoms. Right? Basically, mostly what you need to know about chemistry is over. That and biological molecules. Here's the first term you need to know. Not necessarily because I'm going to test you on this, but I'm going to use this word a lot. What is the smallest component of an element that retains all of the chemical properties of that? The key word there, not for the exam, just for this conversation, but the key word here is chemical properties. So somebody's already turned in an independent, really enjoyed, because they were talking about protons and neutrons and electrons, and they asked, what makes up protons and electrons and neutrons? And in this class, the answer is nothing. As far as we're concerned, a proton is the smallest thing there is. A neutron is the smallest, electron, whatever. But in real life, and you can look this up for independent work if you want, there are actually some, well, these are subatomic particles. Get protons. There are things that make up neutrons. So it can get smaller. Down, you're no longer doing chemical reactions, you're doing like nuclear reactions and things like that. So as far as the smallest, so to speak, the small of an element, and then atom is made up of these smaller pieces that, as far as we're concerned, do not break down. At least not chemically. Any questions about that side? It's very easy, right? You guys have all heard, you know what an atom is. And you need to know this. Atoms are made up. You need to know their charges, which should be easy because it's in the name. Electrons are obviously negative. But protons are obviously positive, right? Positive, right? They have a positive 1 charge. Neutrons, that's pretty obvious. It's in the name. It's neutral. And by process, another thing you need to know is the mass. We're concerned in this class, electron. That will come. That'll be more important a little bit later. There will be a little bit of math when it comes to this. Later, you have some all protons and neutrons mathematically. Thing with the electrons, and you'll know as you do the next lab, people get this mathematically. This relationship between protons and neutrons. So if an atom gets an extra electron, it becomes more negative because it has a negative charge. Does that make sense? If an atom gets an electron, more than that, it becomes negative because electron. If it gives up an electron, or more than 1 electron, it becomes positive. Does that make sense? The last word for attendance, we'll say, is Proton. And we are done for the day, unless you see you in about an hour. Oh, yeah, send me if you don't want to send me an email. Here, I'll write it on this board for you. It's in the syllabus. Or have you received any emails from me yet? Yeah, you could just reply to any of those emails, but just send them to my email address. I was going to write it, but since you should have it.